Welcome back. This is the second lesson recording for IM2, October 26, 2020. So now we're going to try to simplify these radical expressions. Alright, so when you see 4 root 3 minus 2 root 3, the first thing you need to recognize is what is the operation between 4 and root 3. Just like 4a means 4 times a, there is an invisible multiplication here. Okay, so that means 4 multiplied or 4 lots of root 3 take away 2 lots of root 3. So this just becomes 4 root 3 minus 2 lots of root 3. But this is really similar to 4x minus 2x because root 3 and root 3, they're like terms because they actually represent exactly the same value. Okay, so you're saying 4 lots of root 3 take away 2 lots of root 3. So 4 minus 2 is 2. So you'll have remaining 2 lots of root 3 or 2 root 3. This is by combining like roots. So see if you can do these problems. Okay, pause the video if you can figure this out. Alright, so then let's go through it together. 3 root 3 means 3 lots of root 3, and 2 root 3 is you have 2 lots of root 3. So you have 3 lots and 2 more lots of root 3. So how many lots do you have altogether? You have 5 lots of root 3s, or you can just write it as 5 root 3. B, you have 3 lots of root 5, 3 lots of root 5s. Take away one lot of root 5. So 3 minus 1 is 2. So you have just 2 lots of root 5s, or 2 root 5. What about negative 3 root 6 plus 2 root 6? So this is like negative 3a plus 2a. Negative 3a, so if I was to write negative 3a plus 2a, what do? You just negative 3 plus 2 is negative 1. So it would be negative 1a, right? So in the same way, negative 3 root 6 plus 2 root 6 just means negative 1 root 6, which is same as really negative root 6. Okay, let's talk about this. This is negative 3 root 5 plus 3 root 6 minus 2 root 5 minus 2 root 5. Okay, so this, I can rewrite this as, if this is sort of like negative 3a plus 3b, because root 5 and root 6, they are not like terms or like roots, minus 2c, because again, root 3 is not like root 5 or root 6, but then I have another root 5, so which is an a. So I can combine the negative 3a with negative 2a, and likewise I can combine negative 3 root 5 with negative 3 root 5. So then this just becomes negative 5 root 5 plus 3 root 6 minus 2 root 3, because I cannot do anything with simplifying unlike roots. Okay, so that is my final answer. Alright, so then let's try to simplify this. Square root of 75, we said was in between square root of 81 and square root of 64. It's somewhere in between, and we know that it's between 8 and 9. So we know the square root of 75 is between 8 and 9. And if I actually use the calculator, you get square root of 75 is equal to 8.660254038. Okay, that means, and it goes on forever. If I have a more accurate calculator, it will give me more digits. So that means if I say just decide to cut it off here to 2 decimal places and say the square root of 75 is 8.66, that wouldn't be accurate, would it? It's not exact. It's just approximation because I am disregarding all the rest of the decimal places. It's not just 8.66, but it's 8.66 plus a little bit more. Okay, very small, but still a little bit more. Okay, and or even if I went all the way to 9 decimal places after the 9 digits after the decimal place, it will still be an approximation because there will be a whole lot more decimal places, more digits after that I am disregarding. Okay, so when you use the calculator, it is at best a approximation unless you have an integer perfect square. Okay, it's perfect squares are perfect squares. Okay, it's just an integer, but when you are dealing with any numbers that are not perfect squares, it's going to be approximation. And in math, we prefer exact answer whenever possible rather than approximation. Certainly there are times that you want to approximate instead of giving exact answer in real life application problems. All right, so how do we go about doing this? Well, how can I simplify this? I use this product rule of square roots. So you're taking notes on this, which says square root of a times b is same as square root of a times square root of b. So that means if I have square root of 75, square root of 75 is, 75, I can break that up as 25 multiplied by 3, because 25 times 3 is 75. So then I can break each of these as a separate radical. So 25, square root of 25 times square root of 3 is same as square root of 75. And I know that square root of 25 is 5. So it's going to be 5 multiplied by square root of 3. So it's 5 root 3. Similarly, if I have square root of 18, 18 is really same as 9 times 2, and then I can separate each of the product in its own radical as a own radical. So that's square root of 9 times square root of 2. What's square root of 9? That's perfect square, and that's 3. Okay, times 2. So what we are looking for when we are looking for the product, we're looking for perfect squares. So 25 is a perfect square, 9 is a perfect square, and 100 is a perfect square. So we're looking for a number that multiplies with a perfect square. Okay, which has, what is the factor that is a perfect square? For 200, that's 100 times 2. So I know the 100 square root of 100 is 10, square root of 2 is just 2, so it becomes 10 root 2. Okay, so when you are looking to simplify using product rule, the strategy for looking for perfect square factors, you start small, then you move up. So you try 4, 9, and 25, and then you keep moving up. Okay, so if I was to go further, yes, I would need to go to like 36, 49, 64, 81, 100, 121, 144, and so on. Okay, but you start small and keep going from there. So for example, if I have square root of 54, I could say that, okay, square root of 54, is it divisible by 4? No. Is it divisible by 9? Yes. So I know that this is really same as, whoops. Okay, so square root of 54. 54 is same as 9 times 6. So then break up each of the factors as square root of 9 times square root of 6. Square root of 9 is just 3, because 3 times 3 is 9. And then square root of 6 stays as it is, so it becomes 3 root 6. So square root of 54 is same as 3 root 6, and that's the exact answer. Okay, and then likewise, if I was to go to the next problem, square root of 288. Okay, so now I am thinking, okay, that's a big number. Okay, so start small. Is 288 divisible by 4? Yes. So I can say this is same as 4 times 288 divided by 4 is going to be 60. It's 4 times 72. Okay, so then I have, this is square root of 4 times, what about 72? Can I break the 72 as something smaller? Well, 72 is, I can multiply this by 9. 9 times 8 is 72. Okay, so I know the square. So that becomes, what's square root of 4? That's 2. What's square root of 9? That's 3. Now square root of 8, can I simplify this further? Is this divisible by any of the perfect squares here? Well, 4, yes. So that's going to be square root of 4 times square root of 2. So then you have 2 times 3 times square root of 4 is 2. And multiply that by 2. And you have 2 times 3 is 6. 6 times 2 is 12. So that's 12 root 2. Okay. Alright, so I would like you to pause the video and see if you can simplify this yourself. Okay, so you look for perfect square and use the product rule. I am going to go through the answers in 3, 2, 1. So here are the answers. So please pause the video and compare your work with my work. Okay, so we're going to do more simplification. Level 3, you have 3 root 2 plus 2 root 18. Well, it does not look like we have like roots at first glance. But no, when you look at square root of 18, I know that square root of 18 can simplify to be something smaller. Okay, so then I can say, so I know that square root of 18 is same as 9 times 2. 18 is same as 9 times 2. So breaking that up as 9 times 2. So you get 3 root 2 plus 2 times square root of 9 times square root of 2. That simplifies to 3 root 2 plus 2 times 3 root 2. So that becomes 3 root 2 plus 6 root 2, which is 9 root 2. So you have 3 lots of square roots of 2 plus 6 lots of square root of 2. So you get 9 lots of square root of 2's altogether. Okay, so I want you to pause the video and try to do these problems yourself. Okay, pause the video and have a look at my answers and compare your answers against my work and see if you can find any errors or if you find any differences. So in summary, what do we look for when we are simplifying square roots? First thing is you look for perfect square numbers. So like if you have square root of 25, that's going to simplify to 5. Notice that the square root sign goes away when you've actually evaluated the square root of something. A lot of students, this just becomes square root of 25 becomes square root of 5 without the square root sign going away. When you've taken care of the square roots function, then it goes away. It does not keep reappearing here. The next thing is you look for combined like roots. So for example, when you have 3 root 3 plus root 3, that becomes 4 root 3 because root 3 and root 3, they're like roots. Okay, and then perfect square factors in radicand. So if you have square root of 50, then you look for perfect square factors. So I know that 50 is 25 times 2. So that becomes square root of 25 times square root of 2, which is same as 5 root 2. Okay, that's it for today, for this lesson, and the next topic will be continued in the next lesson recording.